Hey all, it's Alex Williams. I'm so excited to be here for this discussion for data on Kubernetes, and we're really looking at databases on Kubernetes. And it reminds me a lot of the discussions I often have with people about how do you think about Kubernetes overall. And it's really gets to the fundamental issues I think that a lot of people are facing. And Kubernetes was built as a stateless environment, but almost everyone has stateful applications. And so how do you think about your storage? How do you think about it on your on-premise versus off-premise? How do you think about the databases themselves if you're thinking about microservices, which Kubernetes really is supposed to be there for? And so I'm really excited for this discussion with my guests. I'd like to go around and have them introduce themselves. Rick, why don't we start with you? Rick Vasquez.
Hi, my name is Rick Vasquez. I'm a technologist. I've been in the data game for quite some time, whether that's at software companies managing data infrastructure, whether that's at database companies creating new versions of databases, or whether that's at hardware companies focusing on how do we store data. So really, I've been pinned into this data world, and I love it. And Kubernetes is something that's near and dear to my heart. I was, I've come full circle. So I used to be very anti-Kubernetes for anything except for stateless, and now I've come full circle, and now I think I'm one of the biggest proponents of putting all of your data in Kubernetes.
Ah, interesting. Okay, well, Mickey?
Thanks, Alex. My name is Mickey. I'm a product manager with the Cloud Native Services Group at Oracle. But Oracle, of course, is a company that's known for a history with databases. So I suppose that's why I'm here. I've been working with Kubernetes for a few years now, and we're starting to do more work on operators and other things that simplify the process for storing databases and other sorts of stateless information within Kubernetes clusters. And I'm excited to talk about some of that today.
Deepti.
Hi, I'm Deepti Sigireddi. I work at PlanetScale as a software engineer, where I work on Vitess, which is the CNCF graduated open source distributed database that works on top of MySQL. I am a maintainer and tech lead for Vitess, both in the open source community and at PlanetScale, where we are building a database as a service, or what we like to call database for developers, which is running on top of Kubernetes, which is built using an operator. So this is very much in the space that we are in. And I have opinions on why we do that.
Well, gosh, where do I start? Because I hear Rick talking about him coming full circle. I hear Mickey talking about his database background clearly with Oracle. And Deepti, I'm curious about your opinions. Maybe we'll start with you, Deepti, about Vitess and like, what is it? And it's an open source project, and it leads to questions about open source and Kubernetes overall. And how do you balance that in terms of the overall equation for thinking about customers who are often built on proprietary architectures themselves, and how do they marry these two issues?
Vitess itself has been around for over 10 years now, and it was open source from the beginning. And it came out of YouTube's problem of how to scale MySQL, because they were running on MySQL and they were seeing explosive growth, and their data architecture at that time simply could not keep up. So I think having been open source, Vitess has benefited from multiple companies, multiple production installs running into different sorts of requirements and contributing those pieces back into open source, which is something that absolutely would not have happened if it had stayed proprietary. The other thing that happened with Vitess very early on is that the YouTube team had to move Vitess from YouTube's infrastructure into Google's infrastructure, which meant that it had to run within Borg, which was a precursor to Kubernetes. So Vitess actually was able to run on Kubernetes very early, 2015, even before Kubernetes 1.0. And this was without persistent volumes, without many of the features that have been added to Kubernetes since then. So it has been possible to run a database on Kubernetes for a while, but it required quite a lot of work to make that actually happen.
So I would love to bring it back to you, Rick, because this probably brings to your journey and around this circle. And I expect in those 1.0 days, you were not as keen about Kubernetes as you are now. Can you take us back to those days when you were first seeing Kubernetes emerge, and what were you skeptical about? And maybe then what has won you over?
So I remember vividly going to a happy hour that we host here in Austin with a bunch of technologists in town, and getting into an argument about putting databases in Kubernetes. And I was very adamant that you should never put anything stateful ever in Kubernetes, but why would you do that, right? It's an immutable container, never change it. If you're going in and even changing configs outside of like the API, you're doing it wrong in Kubernetes is the stance that I used to have. And, we've come a long way.
How did you come to that stance?
How did I come to that stance? Because if your container goes away, or if you have to manage each one of those containers like a VM, you're not gaining anything from Kubernetes at all, right? So now you have this container orchestration that's not orchestrating anything but a bunch of containers that are all different from each other. And how are you're not going to run Puppet and Chef and everything in a bunch of containers. That like defeats the purpose of having your orchestrated everything. So everything should just be configured the same. Every container should be exactly the same. And that's really, I think, where the power of Kubernetes is it doesn't matter where I deploy it. It deploys exactly the same way, whether that's on my laptop, whether that's in a dev or QA environment, or whether that's in production infrastructure. And the main difference is how much resource allocation am I going to give that container? So that was a really big advantage. And I saw that early on with Kubernetes. But what I didn't see is, databases change literally all the time, right? That's the entire point of a database is, maybe the runtime environment, it could be, live in an immutable state, but everything that it's doing is changing data, right? That's the entire point of a database, is to manage data changes. So the two concepts to me just were like oil and water. And really until persistent volumes came around and really there was this big push in Kubernetes to make persistence a first-class citizen, I think it wasn't even, it shouldn't even be considered. And now, like I said, we've come so far from there to now where it really is a first-class citizen. And you should be thinking about, how do I get my data into Kubernetes to leverage all of the consistencies that you can gain from a deployment methodology and pattern. And then really, one of the greatest things about Kubernetes is it's allowed you to get away from your traditional SAN architectures or your network attached storage and having really centralized appliances that have all of your disk and data, and you have to worry about tiering and everything else. Now you can kind of have a disaggregated set of hardware resources that are either direct attached or over fabric, over channels, and have that orchestrated with some type of container system that is just for storage. And that's really exciting that Kubernetes has almost an entire layer that you can develop that is storage only and has nothing to even do with the databases, just to make sure that your data is safe. It's in multiple places. There's replicas available. If you need to, reschedule a pod, that data is always going to be available somewhere. And that's really exciting. And that's something that's happened in really the last 2 years within Kubernetes. I know we've been working towards it for a really long time, but now it's here and it's here to stay. OpenEBS is a leader in the space. You've got Storage OS, you've got Portworx, who got bought for a ridiculous amount of money during a pandemic, all cash, like kind of unheard of type stuff, because people are really pushing to have, hey, I want to get away from just having to buy a storage box and then, put a LUN out there and attach my VM that I'm running for a database onto it. Now I don't really care where my database is, and I don't really care, as long as my data is consistently performant, where that data resides. And that's a big unlocker.
Network attached storage and the appliances, that's Oracle's talk, if you ask me. Mickey, sounds like they were singing your tune. It's like, wait a second, what are you doing here in this group? Horizontal scaling? I mean, vertical is the way to go as far as Oracle's concerned.
So,
am I wrong?
Yes, that is definitely our wheelhouse. For what it's worth, there are still plenty of folks running centralized, vertically scaled architectures. And working in our cloud native services group, I sometimes forget that myself. Now, with that being said, I do want to talk about a few of the ways that we've actually embraced distributed computing and moved towards this cloud native model. So I've been at Oracle for surprisingly a while now, and like over 7 years. And since before I got there, we've had tools like Golden Gate, which is a real-time data mesh platform, and also real application clusters, which allows you to run a single database across multiple servers that access shared storage. And those have been around since before companies were jockeying over whether to use Kubernetes or Mesos as their container orchestrator. There are also some other tools like multi-tenant, which is a container database, but not the Kubernetes kind of container, but that has pluggable databases that make it easy to move between on-premise environments, cloud databases, and even to Kubernetes environments. More recently, there are newer innovations like sharding databases, where you distribute segments of data across different systems, and that can be on-premises or in the cloud. And we even actually now offer sharded databases via Helm charts. So this is all to say that as a company that maybe traditionally wasn't in this space, we are embracing containerization of applications and tools like Kubernetes. Moving forward, we're going to start offering a greater amount of support using operators. I think operators are very, very cool. Alongside things like PVCs and StatefulSets, I think operators allow customers to use more stateful workloads in a more reasonable way. I mean, we can acknowledge that the Kubernetes API was not necessarily built with stateful workloads originally in mind. But the fact is, if we can extend that API to control resources in a cluster that are part of that API originally, or resources outside of a cluster, including other cloud services, or even including things like on-premise databases, I think that ends up being a really powerful tool to connect what people consider to be legacy systems to this new sort of cloud native stateless approach.
So what you're saying is the article worked. No, I'm just kidding.
No, I mean, I'm with you on that. I think that it's really important for us to embrace this change. We're seeing things like El Caro from Google, which is great. I think it's a great first step. It allows you to provision databases within a Kubernetes cluster. But we actually have an operator coming out that does a little bit more than just that. And I'm very excited about it because not only can you provision a very generic Oracle Enterprise Edition database, you can also provision these sharded databases that I was talking about. And each shard is its own pod in a cluster with its own PVC attached. And you can also use it to do things like connect to our autonomous database services, which is just a fully managed database in the cloud, which is a totally alternative approach outside of Kubernetes, or even connect to things like if you have a database deployed on premises, in your data center or even on your local machine, you can use Oracle REST data services to then actually speak to that using an operator deployed to your Kubernetes cluster. So I think that there's some really cool opportunities for innovation that come along with adopting this approach.
Deepti, I want to come back to you because I know you have some opinions. Anything that you find striking in what was just discussed, but I'm also curious about what were some of the changes you've had to make, to adapt to Vitess to the Kubernetes environment and, on PlanetScale over time. And where is it now? I mean, this discussion about operators is important. What is your approach to operators? Maybe you could, help us shine some light on the past here and, and how it reflects on your perspective and operators overall.
So Vitess can be run in Kubernetes even without an operator, but an operator just makes the management part of it much easier. in order to run something like MySQL in Kubernetes, you really needed a few different elements. The first thing is that if the primary that is taking writes goes away, you need a way to quickly detect that and fail over to a replica. Well, it goes without saying that you should be running in replicated mode. Without that, you simply cannot survive a pod restart. The second thing was, even though you're running in a replicated mode, asynchronous replication doesn't cut it either, because if you're running with asynchronous replication, then you will almost certainly lose data when there is a pod restart. So you need to be running in a mode where any changes that the primary took but did not persist to disk before falling down have actually been communicated to at least one replica. And for that, Vitess recommends semi-synchronous replication. The other thing that Vitess does is schedule backups. So even though you may not need to use those backups, it is possible on a failure to restore from a backup and come back online. It should not be necessary if the failure detection and the failover work correctly, but it is there for you to rebuild the cluster if something catastrophic happens. So those are some of the elements that had to come together. At PlanetScale, there was a very robust discussion around whether we should be using persistent volumes or whether we should be using local PVs or just local disk. And ultimately, we came down on the side of using persistent volumes just because the complexity of recovery with local disk is much higher, which means that there is more room for things going wrong. The strategy with local disks is you detect the failure, you fail over to a replica, and then you bring up another replica so that your replica count doesn't go down. So you do have that intermediate state where you are short by one replica. And depending on how many replicas you're running, that may or may not be tolerable. So those are some of the considerations that went into how we did the operator at PlanetScale. And we built the operator using the operator SDK. So there's operator SDK, there's Cube Builder. There are some tools, frameworks that make it easier to build operators so that you're not starting from scratch. Though I must say that the reconcile loop model that Kubernetes controller runtime gives you is a little bit non-intuitive. So when things go wrong, it's pretty hard to reason about which run of the reconcile loop did things go wrong in and why. So I think looking ahead to the future, it will actually be really nice if people are able to simplify how much a stateful application like a database has to interact with the controller runtime in order to provide the availability, durability, all those good things that databases give us.
There's a lot to think about there. And one of the things to think about is the operator keeps coming up, Rick. And operators are still pretty complicated for most to build out and to actually manage and run. And I'm curious, one of the things you talked about with container orchestrators and when you were saying container orchestrators just seemed like they didn't add anything to the game. And, with data, is there the need for, do you think, thinking through like the orchestration of the data? I mean, there are storage orchestrators that we're starting to see, emerge. Does data fit into that as an orchestrator? I'm trying to balance these concepts of orchestrators versus operators.
So I think there's two ways to think about the world. So the orchestration of where do I deploy my assets or my applications, whether that's a database, the storage, all the various different components that are available to your systems. So we're now disaggregating resources and we're saying, hey, what's the best way to play Tetris with my resources so that I can have databases that are far enough away from each other that if one fails, the other doesn't fall over as well. That's, I think, what Kubernetes is masterful at. Then you have another layer above that. And this is where operators come in, because Kubernetes can't be aware of the way that MySQL works, the way that MongoDB works, the way that Postgres works, the way that Oracle works, the way, I could keep going for a long time. And that's what operators really allow for within Kubernetes. In that landscape, you can have a controller that says, hey, I know a lot about MySQL, right? I know what happens with MySQL, and I also happen to know a lot about Kubernetes. So I can take those two concepts and join them together to make something that is a consistent experience. And I think that's the real value in operators. Now, I'll go one step further with a hot take and say, if you're running a database in Kubernetes without an operator, I would say that that's an unsafe mode of operation, because unless you have a 24/7, 365 staffed DBA that's always logged in and just watching like the Matrix, the error logs, I mean, that's what an operator really does. And so you have situations that come up, whether that means replication lag, whether that means your PVC, one of them's blown up, whether that means a pod got rescheduled. How do you stitch back that replication topology? And how do you stitch that back in the database flavor that you have chosen? And then how do you stitch it back into all the services that rely on that? Because not all the services are relying on just the primary, right? Some of these are really heavily reliant on the read secondaries and some of these followers that are available. And so I think the operator is really important to stitch what Kubernetes brings to the table from a disaggregated resource allocation perspective, and kind of the complexities of having a really distributed system that doesn't need somebody doing all of the nitty gritty configuration every time something happens, right? So it's the carrot and feeding. Yeah,
I want to go to Mickey and then finish up with Deepti, because we only have a few minutes. So Mickey, what's that new stitching? What's that new stitching that you're seeing is needed in operators?
I think it's a good question. I mean, we just talked about how there are so many different like keeping the lights on activities for database administration, and there is seriously no need to do that all on your own. I mean, you're more than welcome to. You can try it. You can, run RMAN backups or something to make sure that you have a recent copy of your database and do your own restores. You can do all these different activities that are operationally taxing and add no value to your business. Or you can just use an operator that's built by somebody who knows what they're doing. So I think it's absolutely important to embrace the operator framework and just rely on having subject matter experts develop them for you in a standardized way. I think one thing I also wanted to talk about just very briefly was that we have this strange vilification of people who use stateful applications in Kubernetes. And, part of that Rick talked about previously was related to the fact that Kubernetes initially was not the best source for stateful applications or just any sort of data persistence. But now that we've solved a lot of those problems from a technology perspective, I think it's really important to shift away from vilifying those types of workloads to instead embrace them. I mean, obviously, I'm coming from a company where we have a lot of customers running what people refer to as legacy applications. And, sure, stateless might be the right approach for a lot of container native and probably a lot of greenfield projects and maybe some brownfield ones as well. But we have to acknowledge that enterprises still run a lot of stateful applications and connect to services that aren't running in Kubernetes. And also not every development team has the bandwidth or the expertise to decompose and containerize their apps. So
I got to ask this question because
Sure.
you're going to bring up storytelling and narratives that relate around villains and heroes. I'm going to go down this path for sure. And you talk about vilification. If it, I think a lot of people would wonder, what does that mean, vilification? But mostly I would like to ask, who is the villain? Every story has a villain. Every story has a hero. Who's the villain? Who's the hero?
I would say the hero is just, following the sort of CNCF policies of openness. It's making sure that we acknowledge that every single type of workload has a seat at the table in the Kubernetes space. And the villain, not to name names, but is maybe everybody who's contrary to that opinion. I don't think that we should just exclude these stateless or stateful workloads because they're an artifact of the past or something like that. I mean, there are just so many different people with legacy applications that want to take this container native approach. Oracle has all these massive applications like eBusiness Suite or PeopleSoft. And I have people come to me and say, Mickey, how do I containerize this and then use a CI/CD pipeline to deploy changes to my PeopleSoft? And I'm like, well, that is a question for a completely different panel.
Well, good.
But yeah, anyway.
I hear you.
Yeah, at the end of the day, I just wanted to say that we owe it to the community to both recognize that stateful applications are here to stay, and also to make the onboarding process as simple as possible.
Yep, and they're worth billions and billions of dollars, so they're not going anywhere.
Exactly.
And Deepti, your last thoughts here before we finish it up. Where do you see databases and data orchestrators and orchestrators overall going? What do you see the future of operators and, in these different kind of, conversations we're having? Help us sum it up.
Well, if we look back at the past couple of years, almost every popular database now has a Kubernetes operator. So either the people who produce that database or some third party has figured out how to run the majority of popular databases in Kubernetes, and every one of them has done it via an operator. It's still possible to do it without an operator, but I have to agree with Rick and Mickey that operators are the way to go. Maybe there will be some better way of doing it in the future. But I do also want to say that the people who are building the databases can probably do better in terms of the utilities, hooks, whatever you want to call them, that they provide for people writing operators to utilize in terms of managing the failure modes.
In terms of, so they can do better. So do better in terms of managing the failure modes?
Failure modes, yeah. Failure recovery, failure detection and recovery.
What are the failures that we're seeing them in there? I mean, what could they do better?
Well, in a Kubernetes environment, a pod restart looks just like the process crashing.
So all you see is the process
example.
Yeah,
I have a really good example of this. While I was working on a clustered database solution at one company, we had an operator for it. And whenever the entire cluster went down on start, if you didn't start the pods in the exact order, everything would crash again because it couldn't get back to its correct state. And with just a little bit of change to the database itself to say, hey, I'm the first node up, make everybody elect off of me. That's all it needed to really push beyond that. But the operator's not smart enough to do that. The database isn't smart enough to do that. And Kubernetes has no awareness other than I'm supposed to start these things.
Sorry, Alex. That's really interesting because one of the things we did in Vitess is that components can come up in any order. They will discover each other and eventually settle into a stable state. And it usually takes maybe a minute for that to happen, not hours.
Well, gosh, there's so much here to talk about. I want to thank everyone for participating. I've enjoyed the conversation with Rick, Mickey, and Deepti. Thank you all for your time. We've covered the gamut from orchestrators to operators to mythic villains and heroes, and the next steps in the iterations of databases and data on Kubernetes. Thank you all very much.
Thank you, Alex.
Thanks. Excited for the future.
Thanks.